Great. Well, thank you. And now we have a chance to see some of those familiar faces in this afternoon's panel. So I'm going to introduce our panelists and ask them to pop their microphones and webcams on. So we're going to meet in alphabetical order. Our carbon farmer, Larry Clemens, who grew up in northern Indiana, joined the Nature Conservancy staff in 1992. Larry's the Indiana State Director for the Nature Conservancy, and previously he was the North America Region Agriculture Director for TNC, and he was also an active and very, very valuable CTIC board member. Dr. Jerry Hatfield, who you saw in the video, retired from USDA ARS in January 2020 after a distinguished 45-year research and administration career. His research interests encompass understanding the dynamics of the soil plant atmosphere system with a focus on how to enhance the soil to increase yield stability and climate resilience. And he's spoken all over the country on that. He currently works on translating research into practices that benefit agricultural production and environmental quality. We also met Dr. Cynthia Ribeiro. She is the field program lead for the Bayer Carbon Program. She's been working at Bayer for 8 years, starting in research and currently leading the implementation of the Bayer Carbon Program from its inception. She's passionate about sustainability and is excited to see the momentum in agriculture. And then we have Dr. Ryan Stockwell, Senior Manager for Carbon Engagement at Indigo Ag. Previously served as Director of Sustainable Agriculture for the National Wildlife Federation, working on federal farm bill legislation and implementation toward reducing policy barriers to growers using regenerative farming practices. In his spare time, he practices what he preaches, farming near Medford, Wisconsin, using regenerative practices. So this is a great opportunity, now that you have a little bit of background on our panelists, to ask questions just across the board. So please do ask questions in the question box. What I'm going to start doing is drawing from some of the questions that are already there. There are a couple of questions about additionality. And so I know we talked a little bit about it in the video, but I'm going to reach out and ask Dr. Ribeiro to start, and then I'm going to ask Dr. Stockwell to continue on about how additionality factors into the programs that you're involved with. How do you account for that adding new carbon to the system?
Hi. Thanks for the opportunity. Very excited to be here. That's probably the topic that causes the most problems around carbon. And we at Bayer, we feel very frustrated about the rules, but understanding where it's coming from, I think it helps. And I talked to several farmers that were interested in participating in the program and didn't qualify about this. And the rules come from registries, bodies that issue credits. And the rationale around carbon credits is that we're trying to reduce overall global emissions. And they put rules around how practice are adopted to be able to add practices or make change, so the overall emissions change. That end up preventing farmers that have adopted this practice for the long time to participating. And they create rules about timing of adoption, percent of adoption in a certain geographic area. So the additionality rule plays in multiple aspects on how you create eligibility. I think we are trying to play by the rules now, at the same time taking advantage of how do we help influence and change the way additionality is viewed, because some of these rules were created as it pertained to forestry carbon credits. And I think we're trying to advocate on behalf of farmers that every year this farmer is making this choice, right? And what we don't want to be is having farmers reverse back to old practices just to be able to qualify for a program. So explaining and advocate on behalf of farming to the body of agencies that are starting to work for the first time with agricultural credits, I think is going to be crucial, and hopefully we'll be able to change things for the future. But that's where they're coming from, and these rules are not necessarily our choice, but we are working to improve them.
Brian, what are you
Yeah,
all
Steve,
doing?
and I want to echo. Yeah, I want to echo thanks. Appreciate everybody and CTIC for pulling this group together and all the panels. This has been really fun to watch so far. For me, it keeps coming back to, because I'm actually in that boat. I've been doing no-till and covers for 10 years, and so I personally went through that mental challenge of how come some of my fields don't qualify. I'm going through that process, but it's helpful to keep in mind again the purpose and the one fundamental purpose of carbon credit markets, and that is to cause a net change in greenhouse gas emissions or sequestration. And again, thinking about that and the goal of the market and the goal of the buyers and the demand side, for them, it becomes very difficult and, quite honestly, probably a little really challenging to stand behind a claim when the evidence isn't there that there's necessarily a net change in that sequestration rate or a net change in those emissions. You know, consumers and buyers are very educated, aware, and value-based. And this one component of sustainability, of dealing with the climate crisis, is a key factor in their purchasing decisions. And so they're going to let their dollar speak, and they're going to let it be known when they feel that an entity makes a claim and it rings hollow. And so the fundamental purpose of the carbon market is to allow everybody to participate, to cause that net change, and have that trust so that the buyers of the credits can stand behind that claim with total honesty and confidence.
Great, thank you both. There's a fascinating question on here that I want to keep on the rules for a minute, and this is one from Jordan Beck. It says, will there be a time when farmers will need to be neutral, and how will selling their carbon credits affect that? Can they use their own credits towards that neutrality, or will they be expected to purchase credits? I'm going to take it even a step further and go, if I've sold my credits, have I overextended myself? Who wants to jump on that one?
The crystal ball. Yeah. Yeah, I mean, we're projecting out here a little bit. I can take a first stab at that. I personally, I don't feel comfortable trying to predict if farmers will be regulated in some way. I think for the most part, if carbon markets work, that'll be accomplishing the goal, right? Rewarding the proper behavior and funding growers to make that happen, as opposed to try to eat through a carrot, as opposed to trying to use the stick. You know, we've seen those efforts before to some extent. I think the context of a carbon market is going to be far more effective in making that happen. I'll let others try to answer the question about redeeming past spent credits and charging them in this new account. That's a tough one.
Anybody else want to take that on?
I can also speak without making predictions, right? Who knows? But I don't expect that would happen, from the sense that a farmer would be back charged for credits or lose. If anything, any rule put in place would be forward. But I do think that there is this concept now of how value chains are looking into their overall emissions up and downstream. So most corporations nowadays quantify their emissions, and they're quantifying from their own operations, but they're looking at what their suppliers and downstream agencies are impacting. So if you look at the food value chain, there are many players from farming to the consumer, and all of them are trying to predict this overall. And I think there is a trend moving forward in at what level do you quantify your emissions downstream, and where do you start offsetting them? And in the sense that maybe it's not the farmer that offset their emissions, but that is at the food processing level, where the emissions from the farming, because that's an upstream aspect that goes into there, or is that the food manufacturing? So that everybody's looking at this and everybody's thinking at that value chain. You're thinking, how do we overall reduce the emissions to begin with, and how do we compensate for our emissions, and who does it? It's still yet to be determined, but I think that's where things are playing. And it may not, the farmer may never need to do that because the emissions from the farming may be offset at a different entity downstream.
Great, thank you. I'm going to take a little heat off of our carbon credits experts because you guys have been sweating for a few minutes now, and I'm going to look at a question here that gets instead of looking upstream, downstream, we're looking surface of the soil to the deep soil. There's a question here: if we accumulate carbon, and I'm going to point this to Dr. Hatfield, if we accumulate carbon in the shallow soil, how do we account for the net loss at deeper soil levels? Or why should it be counted, or why shouldn't it be counted? Is there a difference in terms of carbon levels and carbon loss in the upper inches versus deeper in the soil?
That's probably one of the major questions that is getting asked today, is what's the relationship between deep soil and the shallow soil. I mean, you look at all of the different dynamics that are going on. You look at where carbon gets accrued, and basically it's a function of biological activity. I mean, you think about, to expand on what I said in the video in terms of this dynamic between the plant and what happens in the soil, because we're photosynthesizing, we're creating those sugars, we're putting them down, they exudate out of the roots, we feed the microbes, we're turning that organic or carbon over, we get stored, and that's working the upper surface. But if you get a deep-rooted plant, you get something, let's just take alfalfa, for example, which could root down easily 10 feet in some soils. We could be depositing carbon down there that stays in the root system, and so to really be quite honest with you, we don't really understand the relationship between the upper surface and how it accrues carbon and the lower surface and whether it's accruing or losing carbon, basically because we don't have a lot of deep soil measurements over time in different systems that allowed us to look at this. And so we actually have a data set right now we're trying to pour through and say, what's the relationship between the upper 6 and 12 inches and the lower 48 inches across the field even. And so I think this becomes a real question for us. And I think it puzzles a lot of people, but I think as we get into making some of these measurements, we'll have to work that out. Here's also an area in which we really don't have soil carbon models that have been trained on the deeper depths that we could simulate this and say what's happening as well in terms of losses. So that is one of the big questions that you can put into this whole carbon dynamic right now. And just how much carbon does deep rooted crops place down there, and how stable is it?
That's great, thank you. Jerry, I'm going to follow up. You mentioned the idea of testing and sampling and that kind of thing. And in the video, we talked about some of the technologies, and Bill Salas addressed this earlier with Optus, that are remote sensing, that are trying to reduce the cost of sampling or verification, so that more money accrues to the grower. But at this time, and driving the research, what are the methodologies that are being used to measure soil carbon, in an accurate, uniform way?
Oh, now you put those last two pieces on there in terms of the accurate and uniform. But you look at this. I mean, this is again going back to one of those pieces. You think on an 160-acre field across the central United States, that field may have 6 or 7 different soils in it, different pieces in it. You sample all 6 or 7 different soils. I mean, we've run studies where we've actually grid sampled at 150 feet down to 4 feet across fields. I mean, we have a very intense data set. I mean, the variability that exists there, and then you get it down and you sample within that 150 feet, you sample in 15-foot intervals, and you can see even more variability. So the whole soil sampling thing is you can poke a load of holes in a field and get a good estimate of what's there in terms of carbon. But the goal is not to transport all the field to the lab in terms of getting a carbon analysis. And so, I think we have to start thinking about how do we strategically sample a field, and then how do we utilize, and I'll go back to the remote sensing piece of this, because we've been able to take that remote sensing piece, much like Bill was describing. You say, how much carbon is that plant taking up, because we can estimate net primary productivity and gross primary productivity. And then you start looking at that amount of carbon that plant is placed in there, and you do root shoot ratios to say, well, this is what's in the soil in all of this. So you can start looking at this and looking across the landscape and say, can we strategically sample in areas that may represent the extremes of what's being taken up in the atmosphere by the plant, and then looking at what that change in soil carbon is. The other problem is that we all want to measure this in fine temporal scale, from year to year, but unfortunately, it just doesn't respond that quickly. So you get into some of the soil measurements, you may have to go for 5 years before you see that detectable change, but you can see that change within one season in terms of growth that's out there. And so these become pieces of this. So how do we utilize the soil sampling along with other technologies? Bill talked about the models that go with that. I think that we're going to fuse a lot of different technologies together. Can we build some systems that actually would go out and probe the soil and look at something like, let's just imagine now taking something like the Mars system. We sent it to Mars to look at all these different things. As you get something like a Mars system that looks at organic carbon, and you go probe this field, and you just turn it loose on robots and just transmit that data. So I think, in addition to what Ryan and Cynthia said in terms of this future, I think the other piece is going to be the future in terms of technologies that we use to start sampling and evaluating these changes in carbon that are going on, along with changes in soil health. Not only looking at just what carbon changes are, but what does that really mean in terms of water availability, nutrient availability, all the other things that producers are really interested in terms of their productivity.
Perfect, thank you. So, and I'm going to shift this now to Cynthia and Ryan. What are you all doing now within your programs as far as verification or sampling goes? What's the current process, just so that as an agronomist or a crop consultant can tell my growers, kind of what's in store at this stage? Cynthia, do you want to start?
We are working actually with the regrowth team and using Opta's remote sensing technology that he described to validate the practice, both current season as well as historic practices, to determine that baseline that Bill's explained of what's the current status and how to prove the change. We are also combining that with soil sampling. So the soil sampling is done a year after enrollment. So farmers that enrolled last year are going to get soil sampled this year, and we are actually covering all the costs and operations of that soil sampling. So Bayer is coordinating with suppliers to be able to send soil samplers to the enrolled fields at no cost to the farmer. And we'll collect that data and to the point that we are trying to optimize that experimental design. Like Jerry described well, how do you collect meaningful data in a way that you're just not wasting your time? But combining that with the modeling that we'll be doing with the DNDC model that Bill described, we're hoping to understand a little bit of that soil dynamics. That's what we're doing for verification right now. Of course, we're collecting data through Climate View as well to be able to support that model as well as the verification.
Yeah, Steve, and I would say Indigo Ag has a similar approach. So we use a biogeochemical model to project out to the carbon sequestration rate. And we also conduct random sampling of roughly 5% of all enrolled fields every year. And the goal there is to do sort of a spot check on that specific field, but more importantly, we use that data then to inform that model so that it becomes a learning model and can improve its accuracy over time. And again, Indigo Ag, we operate on a very basic premise that no grower should have to pay any funds in to participate in a carbon program. So yeah, all soil sampling is free to the grower. The value is there for Indigo Ag and for the carbon credit buyer to, again, have that certainty and to have that strong confidence in the system. And we're also working with a number of researchers doing extensive research on cropping systems and the relationships between different cropping systems, different soils and climate, and the carbon sequestration rates that we're seeing. So we're trying to push the boundaries and build out the knowledge that feeds into that model so that more and more growers can participate once we have adequate knowledge into that model.
Super, thank you. So I'm going to turn to Larry. Larry, you've grown crops, you're growing carbon now. Isaac Wolford here has asked, he says, carbon building practices have been mentioned a number of times. Can you provide me with at least 5 of the top carbon building practices? So what are you seeing? And we'll open this up to everybody, but Larry, what are you seeing in your work on your own land, and then also in your context of what you see as you travel with Nature Conservancy as the top carbon building processes?
Yeah, well, that certainly is that's actually a tough question. I love Jerry's smile on his face when that was popped up, because it all depends, of course. I think we'd all get that. And I would love to hear Jerry's input here as a soil scientist and spending so many years here. But for me, obviously, when you're looking at the farm field and focusing on the commodity crops and things that we have in the Midwest, certainly the no-till cover crops practices like that are likely going to have some of the biggest gains for carbon into the soil in that system. For me, as I worked on my little farm and realizing that the crops that I was growing there, the corn, soybeans, and wheat, even under a no-till and cover crop system, I was just at the decision point on my farm of, do I keep going down that path with those practices, or do I take a bigger step? And fortunately, I'm not depending on my livelihood for my farm. I have it for enjoyment of my family and things. So that's when we decided to go to prairies and trees, and certainly putting significantly more carbon into the soil and into the biomass. But I'll pause there. Maybe Jerry or Ryan or Cynthia have comments on sort of in those farm fields, any practices I didn't mention there.
Well, Larry, just to follow up on the reason I was smiling, I mean, I think that we all go through the soil health practices and the carbon. We just kind of tick them off. We talk about reducing intensity of tillage. We talk about cover crops. We talk about crop diversity. We talk about adding manures or livestock back in that system, which is not for everyone, but does offer some potential. But what we see is that probably the biggest one right off the top is the intensity of tillage. Once we can take tillage out of the system and go to either strip till or no till, we see that change from a negative carbon balance to a positive carbon balance within one growing season. And that's often a third to a half of a ton right there, or even more, depending on where you're at. And then you add the cover crops on top of that. And really what you're doing is basically extending the time in which you're capturing sunlight and capturing carbon to put back in the soil. And so, and coupling that with the reduced tillage just continues to add that carbon back into that. So those are probably the top two. And on Larry, on your farm, where you've now taken row crops out and put in a permanent crop, now you don't have the tillage, and you have the continuous cover throughout the whole year with a mix of species that go from warm season to cool season. So you've optimized your capture of sunlight and CO2 in there, and so you're going to see a rapid increase. And so you look at all these different things, and I think that Ryan's comment in terms of looking at what practices are out there and the efficacy of each one of those is location dependent, and it's also soil dependent, because we're not going to see the same response on every soil as well. So I think these all become things that producers need to be asking questions about. But I think that there's a lot of information now that at least gives us directionality. They not give us the exact absolute number, but give us direction of where we're going in terms of changing the carbon status of our soils.
I'm just gonna add here, I think Ryan alluded this in the video, but the way you manage those practices also plays an impact, right? So the species that you're choosing for cover crop, the type of termination, the timing of termination, all of that may have an additional impact. And we're learning more about this, but it is ultimately our goal is to be able to make recommendations, but we're keeping pretty flexible right now to the point of the operations in the West. That's where agronomists and crop consultants are so important at this stage, because they can work with the farmer and determine what would be the best for their operations. And we want to make sure that the carbon ultimately does not impact their productivity, which is the ultimate goal.
Well, Cynthia, you bring up a great point, and a large number of our viewers today are agronomists, crop consultants. What are some of the roles that they can play in achieving what you just described, helping farmers achieve the carbon goals and determine where this all fits into their operation without interfering with the productivity? Are there specific kinds of things you see crop consultants and agronomists doing? And I'm going to kind of round robin that too, but Cynthia, we'll start with you since you brought it up.
Yeah, I think Jamie also mentioned it in her presentation, how there's a lot of confusion out there, right? There's noise in the market. There's always an article, and there's a new program, and while similar, they have slightly different, which is good for the farmer. There's options out there. I think now agronomists and crop consultants can help kind of understand what are the differences and how that specific farmer can benefit from one program to another. I think diversity is ultimately good for the farmer. We try to keep our program pretty flexible, so we are not requiring farmers to adopt no-till and cover crop together. They can choose the practice that best work for their operations. No-till or strip-till is not going to work for everybody. Cover crop's not going to work for everybody. So we decouple that from our program so that farmers can choose what best work for them. And I think crop consultants can play a big role in helping them choose that. Is this the right time? They can also stack those later on. So today I maybe start with strip-till, eventually evolve into no-till, eventually evolve into adding cover crop, and their payments stack up that way. I think the other thing is helping them understand a little bit of, is it the right time to participate? I think the other confusion out there is, will the price go up? Should I start now? If I start now, am I going to be prevented from a bigger piece of the cake later on when things hopefully get better, right? I would say my personal, and maybe I'm biased, but I try to think about it, why not participate now, right? We heard from everybody that the benefit grows over time. So the longer you stay, the longer you the earlier you make the chance, that sooner you're going to see the ultimate benefits. Other things that are in place in other programs is that value of the carbon credits may grow. So we have a strong commitment that if carbon credits go up, our payment to the farmer will go up. I can't predict how that's going to go. The 369 program that we have today, $3 per acre per year for no-till, and 6 for cover crop, and a total of 9 for both. It's based on what current levels are. If these numbers change, it will change. So why not start getting paid now and then eventually take advantage if that market changes? So that's my personal opinion, where I think crop consultants can help, and I'm open to the others too.
Yeah, and And I would like to add to that, Steve, that and same with Indigo program, that our carbon credits are following the market, and our goal is to share as much of that and to get as much return as possible to the growers. So they will see, again, get into the program now, and you'll see that growth and can participate in that upside with Indigo Ag. I think for crop consultants particularly, and again, I agree with Cynthia in terms of their role of helping provide that knowledge and insight to help growers think about these practices. I think one specific application is helping growers to see the changes in their soil over time. I think for a lot of growers, this is pretty new territory, and they really, really don't know what to look for. What do I look for when I go to no-till? How do I know that I'm actually having success getting to where it is that I want to go? I'm not even sure where it is that I want to go with this. What should I be looking for? So the more information you can help growers provide them with that feedback to the system so that they know they're on the right path, they're going to lean into you as a trusted advisor. So I think that's a really important component to helping growers out there.
Steve, I'll just piggyback with what Ryan has said, and not only in terms of looking at what's going on in the soil, but we talk about these changes, reducing tillage intensity, adding cover crops, the diversity, and you look at all the tweaks that producers make from one season to the next. And I think that one of the roles of the crop consultants is really to help that producer understand not only what's changes within their soil, but how they're managing their crop, how they're managing their overall system in terms of really an adaptive management perspective, and saying, I do this, I look at these changes that have occurred during this season, what tweaks do I have to make for the next season to optimize the performance out of that so that profitability isn't at a risk, productivity isn't at a risk. And I think that becomes a role of that consultant that has an expanded view in terms of not only looking at how do you manage this season, but looking forward, looking at the past season, and then looking at the next couple seasons to say, here's some things that we need to be paying attention to and all the different dynamics that are going on. And I think that in all of this, we're going to see a greatly expanded role and value of the crop consultants in terms of our farming practices across the United States.
Yeah, Steve, I would agree with all three of the other panelists here. I think the agronomists play a key role here. As I was thinking about this question and hearing the responses too, and I know it was raised earlier, and I think each one of the speakers that represent various programs have mentioned this to some extent, but I do think in the long run here, for success of sustainable agriculture and greenhouse gas reduction and farming, participating in that, we got to make sure the landowners are somehow in this conversation. If we don't bring them along, eventually we're going to have to catch them up to the conversation. Or, as we're all seeing right now, a lot of landowners that are buying farmland as investments and things like that actually have a lot of questions about this and perhaps are even driving it. So let's make sure we bring those landowners into that conversation with the grower and the consultant if possible. And I know that's complex. That's without a doubt complex, but it's necessary, I believe.
Yep. It's a great point, Larry, and noting that those conversations may be different, significantly different between the producer on the ground renting versus the non-operating landowner. One piece of information that agronomists, crop consultants are probably going to be asked about is something that was asked in this lineup of questions, and that is soil saturation. How do you measure soil saturation? How do we know when a particular soil or soil type or parcel is saturated? And I see Jerry smiling because I suspect that the words "it depends" is going to factor heavily into the answer.
Well, the reason I was smiling is I'm thinking back to the organic matter plots that came out of the Morrill plots and the Sanborn plots. I mean, we were at 7, 9, 10% organic matter across the upper Midwest. We got fields that are 2 to 3% right now. We've got some that have changed up to that 6 to 7. You know, I think we'll see this continual accrual. I mean, you look at this. I think it will depend upon all these different practices and how they come together. But I'm not sure that saturation is something we really need to be worried about right now. I don't think that we are really going to get to the point of saturating our soils. I'm not going to convert Larry's carbon farm into a peat bog by adding that much organic matter into it. It's going to be a self-regulating thing. I mean, just look at the prairies in terms of where they're at. You know, I think if we put a parcel back into permanent cover, you know, we continue to manage the nutrients so we optimize the carbon going into that. It'll be a while before it gets there, and then it'll reach a steady state condition. You know, and so, I mean, that's the way ecology works, is in steady state. So, you know, we'll balance it out, and then it'll get to its optimum point. You know, and so I guess I don't worry too much about saturating it. I think that it really begins to work itself out at the long run.
Super. Now, I have promised Chris and Lacey that we would be timely, and I would love to spend another hour answering these questions. There's a lot of great questions, and I'm hoping that we've captured them in some way, because I'd like to somehow continue the dialogue. But at this time, I just want to thank our panel. Cynthia, Ryan, Jerry, Larry, you've been a wealth of information, and I really appreciate, we all do, all the time and expertise that you've shared with us. Again, we'll try to find ways to continue this conversation, either through our website at ctic.org or other manners. But I'm going to ask Chris to just put up our slide too that thanks our sponsors, because as he noted earlier, we can't do it without them. They're the ones who've made this possible for free, and we're really grateful for the opportunities that those sponsorships have provided. We will be back on August 3rd as part of the August 3rd program. We'll be talking about phosphorus credits and BMPs to reduce off-farm nutrient flow as part of the American Society of Agronomy's program that day. And then we'll have 2 more beyond that.